Hey folks, I'm Karman Dadich, Technical Marketing Engineer from Cisco Security Business Group. In this video, we will be talking about the new feature in the latest Cisco Secure Threat Defense 7.6 release. The new feature I am referring to is dual arm deployment of firewall behind gateway load balancer in AWS. We will start by first understanding the differences between new dual arm deployment and the existing single arm. We will take a look at a specific demo on how you can configure FMC for the dual arm architecture. Lastly, we will verify the results of our config, so let's get started. The difference between single and dual arm are quite easy to understand. For the single arm architecture, the packet originating from your inside server will be sent to gateway load balancer, which will send it to the firewall. Firewall, after inspection, sends it back to the gateway load balancer, which then sends it to the NAT gateway and later to the internet. However, in the case of dual arm deployments, the traffic once sent to the firewall by gateway load balancer will then be simply routed to the internet via the outside interface of FTD. The packet here is not sent back to the gateway load balancer, hence optimizing the solution. If we add gateway load balancer endpoint into the mix, the total hops needed for egress traffic will be reduced by 2, which actually is quite a significant improvement over the single arm architecture. For the purpose of this video, I have already set up two Cisco Secure Threat Defense Virtual behind a gateway load balancer, registered to one FMC. And this is how the whole topology will look like. We have our gateway load balancer and firewalls in a service VPC. And then we have one spoke VPC where our application servers are present. These two are connected via a transit gateway. The aim is to make sure that our server app1 with 10.0.1.189 IP can reach the internet. The outbound flow will look something like this. With the help of route table configured on each subnet, the packet from our app1 will be sent to the transit gateway first, from where it will be handed out to our transit gateway interface, which is present in its own subnet. Packet will then be routed to the gateway load balancer endpoint, and by default, endpoint will send the packet to gateway load balancer. Gateway load balancer will send it across to one of the firewalls inside interface. After inspection, the firewall will send it to the internet gateway via the outside interface. Let's take a look at how you can configure dual arm deployment on FMC. Head on to Device Management from the Devices tab. Select the device that you want to edit. And let's start by editing our interface 10 Gigabit Ethernet 00. We will name this interface as outside. Make sure that you enable the interface. And if this is a fresh deployment, you'll have to create a new security zone called outside. Under the IPv4 tab, select the IP type as DHCP and leave everything as it is. In the similar fashion, you'll have to configure the inside interface. Head on to VTEP after you have configured the interfaces. Enable NVE. VTEP is used to form a Geneve tunnel between the gateway load balancer and your devices. Select the VTEP source interface as inside and leave everything as it is. Make sure that the encapsulation type is set to Geneve. Save the configuration. Now, let's go back to the Interfaces tab. We will be creating a virtual network interface here. Click on Add Interface and then VNI Interface. Name it as VNI. You will have to create a new security zone here. So click on New and then create your VNI security zone. You can pass any ID. For example, I'm passing 1. Make sure you select enable proxy and then dual ARM. This is the place that actually decides what kind of gateway load balancer topology it will be supporting. Enable NVE map to VTEP interface. For everything else, leave them as it is. Save the configuration. Now, let's head on to our routing tab. We need to create some routes to ensure that the traffic goes to the outside interface when needed. Go into routing and then static route. Click on add route. Select the outside interface. For your available network, select any IPv4. You'll have to create a gateway that essentially is the outside gateway for your network. In the AWS deployment, my gateway is 3.1. Assign that gateway to the route. And once this is done, click on OK. This is essentially the route that will send traffic to the internet. Optionally, you can create another route for your east-west traffic flow. For that, select the interface as VNI. Pass the network of your inside LAN. Select your inside gateway. Click on OK. Once you are done, remember this is an optional route. For your outbound traffic, this won't be needed. Click on Save. Your device is now configured. Head on to Policy and Access Control. Here, we will be creating an access rule to allow the traffic pass via the firewall. Under your access control policy, click on Edit. And then click on Add Rule. We can change the name of this rule to VNI to Internet. For your source interface, select VNI, and for your destination zone, select outside. Select the source network of your inside LAN. In our case, it will be 10.0.0.0/8. Make sure that you turn on the logging and set it to at the end of connection. Once everything is done, click on Add and save the rule. This rule will essentially allow the traffic coming from our inside LAN via the VNI interface to go to the outside interface. Since we have enabled logging, we will be able to see the connection events of this as well. Let's now move on to NAT policy. Click on Devices and then NAT. Create a new policy. We will name it as FTD NAT policy and we will assign our targeted device to it. Once created, we will add a rule. Change it to an AutoNAT rule. Let it be static, and under the interfaces object, add VNI as source and outside as destination. Go to the Translation tab and add your inside LAN as the original source. For the translated source, we will just use the destination interface IP. Leave everything as it is. Click on OK. And then save the rule. Once a NAT policy is in place, we will now need to provide SSH access to our inside interface. This is used by our gateway load balancer for its health checks. Head on to Devices and then Platform Settings. Create a new Threat Defense settings. We will name it as FTD Platform Setting and we will assign our device to it. Once it is ready, we will go to SSH Access tab. Here, click on Add. For IP address, I am selecting any IPv4 here. You can also just pass on your inside LAN IP. Select the interface as inside, click on OK, and then save it. The final step would be to simply push the changes to the device. Click on deploy and then deploy the FTD you are intending to push the changes to. Once the deployment is completed, we can go ahead and try to verify our configuration by accessing the internet from the inside machine. Okay, now let's switch to the console of our inside machine. We will first try to ping 888 just to check internet connectivity over ICMP. And as we can see, the ping is going through, thus stating that our configuration is overall working. We can also try curling a few sites. So let's curl https www.cisco.com. We are getting a response. So TCP over 443 does seem to work. Lastly, we will just do another curl for google.com. Lastly, we will also check if the traffic is actually passing through our firewall via the connection events. We want to absolutely make sure that the traffic is going through the firewall and not directly to the internet gateway via some other routes. For that, let's go back on our FMC, click on Analysis, under Connection, click on Events. Here, you should be able to see from your inside machine, which is our 1.189 machine, traffic that is going to the 888. Also, you can see traffic routing to the web application, Cisco and Google as well. Keep a note of the ingress security zone and egress security zone. Those are set to be VNI and then outside, which was our intended purpose. That's it. You have successfully configured your Cisco Secure Firewall to support dual ARM gateway load balancer architecture on AWS. As always, guys, links to everything needed will be in the description box below. Thanks for watching. See you guys later. Bye.